Let's talk about selecting random values in Python. If you need a random integer, you can use the randint function from Python's random module. This function accepts a start value and a stop value, and it returns a random integer between the start and the stop value inclusively. The random module also includes a range function, which is named after Python's range function. This function accepts the same values as range: a stop value, a start and a stop value, or start, stop, and step values. The range function basically chooses a random number within a given range. When I need a random number, I usually use randint. What if you need a random floating point number? The random function generates a random number between 0 and 1. If you need a larger random number, you can multiply the return value by another number. I find that I very rarely need the random function because I often need random integers, not random floating point numbers. What if you want to randomly select a value from a list? You could use range with the length of the list and then index the list. But there's a better way. The random module's choice function will return a random value from a given sequence. If you need multiple random values, you could use the choices function. The choice and choices functions work with any sequence, not just lists. When I think I need a random number, I often realize that I actually want a random item from a sequence. So I use the choice function more often than any of the other functions in the random module. Note that the utilities in Python's random module generate pseudo-random numbers, not true random numbers. All of these utilities rely on the Mersenne twistor generator, which uses a deterministic algorithm. Because it's deterministic, we can actually set its initial starting state with a seed value and make predictable random numbers. This generate code function relies on the choice function from Python's random module to generate a string of random characters. The test generate code function uses the random.seed function to set the internal state of Python's pseudo-random number generator to a fixed value. The next time any utilities in the random module are used, they'll generate the same reproducible pseudo-random number as any other time that code ran with the same random seed. For us, that means that our tests pass predictably, no matter how many times we run them. The reproducibility of pseudo-random numbers is useful for automated tests and for debugging, but this feature can also pose a security risk. Python sets a default initial seed based on the current time. If that initial seed might be guessable, either by a sample of random numbers generated or based on the time the code was run, it's possible that someone running the code could determine the next random number that it might generate. For many purposes, the deterministic nature of the random module is probably fine, but if your random numbers are being used for security purposes, or they need to be cryptographically secure, you probably shouldn't use the random module. If you need random numbers that have no risk of being guessed, you'll need to use Python's secrets module. The secrets module includes a choice function, which returns a random value from a given sequence, just like random.choice. But unlike random.choice, this isn't a pseudo-random selection, it's truly random. The secrets module also has a random_bits function, which generates a specific number of random bits and returns an integer that represents those bits. But unless you really need random bits in particular, you'll probably instead want to use another function in the secrets module, rand_below. The rand_below function returns a random integer between 0 and a given number. Here we've generated a number from 0 to 99, and here we're generating a random dice roll. The possible numbers that rand_below generates are the same as the possible numbers generated by random.randrange, when given a single stop value as an argument. Namely, rand_below includes 0 in its possible return values, but it doesn't include the given integer. The secrets module doesn't include all of the other functions from the random module, like random, randint, choices, or randrange, at least not at the module level. The secrets module includes a SystemRandom class, and instances of this class have a random method, a randint method, and the choices method. All of the functions that exist on the random module exist as methods on this SystemRandom class. This SystemRandom class is based on the random.random class, which is the behind-the-scenes class that each of the random module's functions actually use. But unless you really need cryptographically secure versions of functions besides choice and rand below, you probably don't need to dig any deeper into the secrets module. For fast pseudo-random number generation, you can use Python's random module, which uses a deterministic algorithm to generate predictable, random-looking numbers. For true randomness, you can use the secrets module, which generates cryptographically secure random numbers. For most applications of random numbers, the random module is good enough.